Now next question. An urn contains 25 balls, of which 10 balls bear a mark X and the remaining 15 bear a mark Y. A ball is drawn at random from the urn. Its mark is noted down and it is replaced. If 6 balls are drawn in this way, find the probability that all will bear X mark, not more than 2 will bear Y mark, at least one ball will bear Y mark, and the number of balls with X mark and Y mark will be equal. So here in this experiment, in this urn, there are 25 balls, out of which 10 balls bear X mark and remaining 15 balls bear Y mark. Total there are 25 balls. Now a ball is drawn. We suppose that a ball drawn bearing mark X, we consider this event as success. So in experiment of drawing a ball randomly from this urn, we take success is event that a ball which is drawn is bearing X mark. So this event we consider success. Say here 6 balls are drawn in this way, but with replacement. A ball is taken before acting second trial, replace previous one. So every time status of this urn remains same. Every time number of ball remains same. So each action or each event is independent. So all these events are independent. So here in this number of trials there are 6 trials. All trials are independent and probability of success, that is probability of bearing a ball with X mark. Total 10 balls. So 10C1 upon 25C1, that is 2 by 5. So X is, so Q is 1 minus P, that is 1 minus 2 by 5, that is 3 by 5. So N, P and Q. Now we take random variable X as number of successes. So range of X is, here X equal to small x. So this number shows number of successes, and range of X is, say here number of trials are 6. So 0 to 6. So this is range of X. X takes these values, maximum 6, minimum 0. Now formula to find probability that X takes value X, it is equal to NCX P raised to X Q raised to N minus X, binomial distribution. So it is equal to NCX, N is 6, 6CX P raised to x, P is 2 by 5, 2 by 5 raised to x, Q is 3 by 5 raised to 6 minus x, and value of x is 0 to 6. So this is formula. Using this formula we can calculate required answers. So now we are taking one by one. First of all, answer of question 1. All will bear x mark. Probability that all will bear x mark. That means number of success is 6. So here success means a ball is bearing x mark. So all 6 ball will bear x mark. That means number of success, every time we are getting x mark, so number of success is 6. So probability that x assumes value 6. Probability of 6 success. So 6 is 6 into 2 by 5 raised to 6 into 3 by 5 raised to 0. 6 minus 6 is 0. So that is probability that x takes value 6 is equal to 6 is 1. So 1 into 2 raised to 6 upon 5 raised to 6 into 1. So this can be calculated using calci. Now see second question. Not more than 2 will bear y mark. Success we have defined by x mark, and question is about y mark. So we have to understand, we have to convert these terms, this statement which is in terms of y into x mark. So see here showing explanation to understand second statement. Not more than 2 will bear y mark. Not more than 2 will bear y mark. That means not more than 2. That means 2 or less than 2. That means 2 or less than 2 will bear y mark. Now see here I put x and y. 2 or less than 2 will bear y mark. That means number of y marks can be 0, it can be 1, it can be 2. So this means y mark 2 in 2 balls or 1 ball or 0 balls. So 2 or less than 2 will bear y mark. So not more than 2 will bear y mark. Now when 0 is number of balls 0 having y mark, so at that time number of balls having x mark will be 6. When number of balls having y mark is 1, at the same time number of ball having x mark will be 5. Because we are taking 6 balls, there are 6 trials, so total should be 6. And when 2 y mark ball, that means at the same time 4 x mark ball, so total 6. So this means what? When number of balls bearing y mark is 2 or less than 2, that means number of x mark ball is at least 4, minimum 4, not less than 4. So 4 or more than 4. So this is same as This is same as at least 4 balls. At least 4 balls will bear X mark. So now, probability that not more than 2 will bear Y mark, it is equal to probability of this event, that at least 4 balls will bear X mark. So required probability is, therefore, required probability is probability that number of success at least 4, number of success 4 or more than 4, that is probability that X assumes value 5 or value 6, value 4, value 5, or X takes value 6, 4, 5, 6. So now we calculate this sum using this formula. So it is equal to, now putting X equal to 4 here. So 6C4 into 2 by 5 raised to 4 into 3 by 5 raised to 6 minus 4 is 2. So this is equal to, now 6C4 is 6C2. 6C2 is 6 into 5, 30, 30 by 2, that is 15. So this value is 15. 15 into 2 raised to 4 into 3 square upon 5 raised to 6. Sorry, we missed 2 more numbers. X equal to 4, so putting here 4, 6C4 into 2 by 5 raised to 4 into 3 by 5, 6 minus 4 is 2, plus, now for X equal to 5, now I am putting here 5, so 6C5 into 2 by 5 raised to 5 into 3 by 5 raised to 1, plus, now I am putting 6, so putting the 6 here, 6C6 into 2 by 5 raised to 6, 3 by 5 raised to 0. So this is equal to 6C4 is 15. 6C4 is 6C2. So 6 into 5 upon 2 into 1. So 30 by 2, that is 15. So 15 into, this will be 2 raised to 4 into 3 square upon 5 raised to 6. Plus 6C5 is 6C1, that is 6. So 2 raised to 5 into 3 raised to 1 upon 5 raised to 6. Plus 6C6 is 1 into 2 raised to 6 upon 3 raised to 5. Now see, we are taking common. So here 5 raised to 6 is common. 5 raised to 6 is common. And from numerator, 2 raised to 5 is common. From numerator, 2 raised to 5 is common. So 2 raised to 5 common upon, here 2 raised to 4 is common. Minimum is 4. 4, 5, 6. So 2 raised to 4 upon 5 raised to 6 is left. Now how much is left inside? 15 into 9. So 105 plus. Here 2 raised to 4 is taken out. So 2 is left. 2 into 3, 6. 6 into 6, 36. Plus. Here 1 is left. 2 raised to 2 is left. That is 4 is left. So this is 36 plus 4, 40. So 145 into 2 raised to 4 upon 5 raised to 6. So this is equal to, now here we can cut a 5. So 29 into 5, 145, 29 into 2 raised to 4 by 5 raised to 5. So this is required probability. This can be also calculated using a calculator. So it was answer of question 2, that what is the probability that not more than 2 will bear Y mark. Now at least one ball will bear Y mark. That means again we understand this by taking numbers. At least one ball will bear Y mark. So at least one, that means one or more than one. So one ball with Y mark, 2 ball, 3 ball, 4 ball, 5 ball, 6 balls. So this means at least one ball will bear Y mark. Now one ball will bear Y mark, at the same time 5 ball will bear X mark. We have to find number of balls having X mark, corresponding number of X mark, because here we considered X means number of success and success means X mark, not Y mark. When Y is 2, X is 4, then 3, 2, 1, 0. So when at least one ball will Y mark, that means number of X ball is at most 5. That means at most, it means at most 5 balls. Five balls will bear X mark. Maximum 5. So this means probability of this event is equal to probability of this event. Probability of this event, it is equal to probability of this event. So required probability is, therefore, required probability is probability that number of success is at most 5. Success means X mark, so at most 5, so X is less than or equal to 5. So X is less than or equal to 5, that means probability of 0 plus probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5. So probability that X takes value 0 plus 1 plus 2 plus 3 plus 4 plus 5, 0 to 5. Now see here, X, range of X is 0 to 6, and because this gives a probability distribution, probability of 0 plus probability of 1 plus probability of 2 up to probability of 6. So sum of probabilities of these values is 1. Sum of probabilities of these 7 values, see probability of this, these are 7 numbers. So sum of probabilities of these 7 numbers is 1. So that means here we require sum of probabilities of these 6 numbers. Sum of probabilities of these 7 numbers is 1. So sum of probabilities of these 6 numbers is 1 minus probability that X takes value 6. So if you can do, you can bypass this step, you can write directly this step if you don't do any mistake. So I am putting this in bracket. This is not compulsory in exam. Direct you can put this statement. So that is 1 minus, now putting here 6. So 6 is 6 into 2 by 5 raised to 6 into 3 by 5 raised to 6 minus 6 is 0. That is 1 minus 6 is 1. So this is 2 raised to 6 upon 5 raised to 6. So 1 minus 2 raised to 6 upon 5 raised to 6. This can be calculated using calculator. You can calculate this value. By taking LCM, you can solve this now. Then fourth question was, what is the probability that number of X mark ball and number of Y mark ball are same? So balls bearing X mark and Y mark, both numbers are same. So number of ball bearing X and Y mark are same. That means both are of 3 number. So that is X mark ball 3 and Y mark ball 3, then it will be 6 trials. So what is the probability that number of X mark ball and number of Y mark ball are same when this is performed? So that means it is equivalent to, say, number of success 3. When X is 3, at the same time Y will be 3. So required probability in fourth case is, so required probability is probability that number of success 3, that is formula, it was 6cx. So 6cx, p was 2 by 5 raised to 3, 3 by 5 raised to 6 minus 3, that is 3. 6c3 is 6 into 5 into 4 upon 3 into 2 into 1, that is 6c3. This is 2 raised to 3, this is 3 raised to 3 upon 5 raised to 6. So that is here 3 into 2, 6. So this will be then 2 raised to 3, this is 2 square, so 2 raised to 5 into 3 raised to 3 upon 5 raised to 5. You can calculate this using calci or keep as it is. So it is required probability. In a hurdle race, a player has to cross 10 hurdles. The probability that he will clear each hurdle is 5 by 6. What is the probability that he will knock down fewer than 2 hurdles? Knock down, that means he cannot clear, he fails, that is knock down. So say here number of hurdles 10, so number of trials is 10. We define success. Success we define as the player clears the hurdle. He will clear hurdle. Player will clear hurdle. So that we define as success. So probability of success, probability that he will clear the hurdle is 5 by 6. So probability that he will knock down, that is 1 by 6. 1 minus p, that is 1 by 6. Now see, we are asked probability that he will knock down fewer than 2 hurdles. Knock down fewer than 2 hurdles. explaining meaning of this word. He will knock down fewer than 2 hurdles. That means, say here, knock down fewer than 2. Fewer than 2, that means less than 2. So that is 0 and 1. So in 0 trials he will knock down. Here 1 trial he will knock down. 0 times he will knock down, 1 time he will knock down. That means fewer than 2 times. He fails to cross the hurdle. That means he will clear. How many times? So when 0 times he cannot clear, that means 10 times he can clear. When 1 time he cannot clear, that means 9 times he can clear. So meaning of this is that he will knock down fewer than 2 hurdles. It is equal to, it is same as he will clear at least 9 times or at least 9 hurdles. So at least 9 hurdles means 9 or 10 hurdles. So required probability is, therefore here required probability is probability that number of success x, it is equal to, before taking number of success and formula everything, let me define what means success, what is formula. So here let x be the number of success. And probability that x takes value x, probability that x takes value x is ncx p raised to x q raised to n minus x. That is, probability that x takes value x is, here n number of hurdles is 10. So 10cx into 5 by 6 raised to x into 1 by 6, q is 1 by 6 raised to 10 minus x. And here we can take value of x from 0 to 10. So required probability is probability that number of success at least 9. So from this word I am putting here statement at least 9. He will clear at least 9 hurdles. Clearing 9 hurdles. So 9 or more than 9. At least 9. So that is probability that he clears 9 hurdles or he clears 10 hurdles. Putting here 9, so 10c9, 5 by 6 raised to 9, 1 by 6 raised to 10 minus 9 is 1 plus, now putting 10, so 10c10, 5 by 6 raised to 10, 1 by 6 raised to 1. Now 10c9 is 10c1 and 10c1 is 10. This will be 5 raised to 9 upon 6 raised to 10 plus 10c10 is 1. So 1 into 5 raised to 10 upon 6 raised to here this is 10, this will be 0. 10 minus 10, 0. So 5 raised to 10 upon 6 raised to 10. So that is, now here we can take common. See 5 raised to 9, Here also 5 is included, so 5 raised to 9 into 5 is 5 raised to 10. So 5 raised to 10 by 6 raised to 10 is common. Inside here 2 is left. So 2 plus 1. So that is 3 into 5 raised to 10 upon 6 raised to 10. It is required probability. A die is thrown again and again until 3 sixes are obtained. Find a probability of obtaining third 6 in this 6th throw. Third 6 in the 6th throw. Die is tossed again and again until 3 sixes are obtained. Say like this. Here suppose this is first throw, this is second throw. Here I will put outcomes. Third outcome, third throw, fourth, fifth, and we need third 6 in the 6th throw. So 1, 2, 3. This is first throw, second throw, third throw, fourth throw, fifth throw, and this is the 6th throw. Third 6 we want in 6th throw. So here we need third 6. That this is fixed. Here it is fixed. In 6th throw, third 6. In 6th throw, third 6 is fixed. So this is third 6. That means first 2 sixes we need in this first 5 trials. So in first 5 trials, that is trials, we need 2 sixes. Two sixes. That means this is allowed. In first throw and second throw there are 2 sixes. Then third 6 must be in 6th throw. Here no 6 allowed. Or if in second throw there is 6, in third throw there is 6, then third 6 must be in 6th throw. This is allowed. Or here this is allowed. Third 6 must be in 6th throw. That is the condition. So here we need only 2 6 anywhere in any 2 throw. So in 5 trials we need 2 sixes and direct third 6th we need in 6th throw. This is the requirement. So we can explain these as, suppose here we take number of trials. Here number of trials n is equal to 5 for first 5 throw. This is for first 5 throw. We define success. Success we define as 6 is obtained. That is success. So probability of success, when we toss a die, probability of getting 6, that is 1 by 6. So probability of not getting 6 is 5 by 6. So P, Q, number of trials 5. So probability that X takes number of success X here for these first trials. To find number of probability of number of success, formula is NCX P raised to X Q raised to N minus X, where X is 0 to 5. We are talking about first 5 throw. In first 5 we need 2 6s. So probability that 2 6s are obtained in first 5 throws is equal to probability that number of success is 2. 2 6s, that means 2 success in 5 trials. So putting here 2, n is 5 trials, 5c2, p is 1 by 6, probability of success 1 by 6 raised to, x is 2, 5 by 6 raised to, 5 minus 2 is 3. So this is 5c2 is 5 into 4 upon 2 into 1, 10 into 1 by 36 into 125 by 216. So 10 into 1 by 36 into 125 by 216. So 5 into 2 10, 6 into 6 36, 18 into 6, 18 into 2 36, 5 into 2 10. So taking a product of these numbers, 125 into 5, that is 625 upon 216 into 18, 8 into 6 48, then 8 into 1 8 plus 4 12, 17, 3 8 8 8. So this is a probability that 2 success in first 5 throw. So now in this question is that what is the probability that third 6 in the 6th throw. So probability that third 6th is obtained in the 6th throw, it is equal to third 6 in 6th throw, that means occurrence of this event and occurrence of this event is must. So probability of this event into probability of this event. So that is probability of event that probability of 2 6s in first 5 throws, 2 6s in first 5 throws into probability of 6 in 6th throw, probability of getting 6 in 6th throw. So here independent events. If we consider this event as event A, this is suppose event A and this is event B, then what we need? We want A intersection B. Here we are finding probability of A intersection B, that is probability of A into probability of B, because these are independent events. Now this probability here we have found, this is 625 upon 3888 into probability of getting 6 in 6th row. So in 6th row, probability of getting 6. Independent event. Concentrate or focus only on this action. That here you are tossing a die. What is probability of getting 6? So it is 1 by 6. So by using calculator, you can calculate required probability. A leap year is selected at random. What is the chance that it will contain 53 Tuesday? Say leap year, that is 366 days. 366 days, that is 52 week. Number of weeks 52 plus 2 extra days. 2 extra days. 52 weeks plus 2 extra days, that is leap year. Leap year contains this set of elements. Now, possible 2 extra days. Say this 52 weeks, it contains 52 Tuesdays. So 53rd Tuesday depends on these 2 extra days. 53rd Tuesday, it depends on these 2 extra days. Here 52 Tuesdays are fixed. For 53rd Tuesday, we focus on these 2 extra days. Now possible extra days. Possible 2 extra days that we put in sample space. Possible 2 extra days are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday. See, check all possibilities. 1, 2, 3, 4, 5, 6, 7. So these are possible pair of extra days. Now for 53rd Sunday, required event is Tuesday. We are asked about Tuesday. See, any day can be given. In this question, instead of Tuesday, if you are given Sunday, Monday, Tuesday, Wednesday, any day given, calculation will not be affected. So for 53rd Tuesday, required event. So here this is 53rd. If these 2 days occur, then this will be 53rd Tuesday. Or this event will occur, this will be 53rd Tuesday. In extra 2 days, occurrence of these elements are required for 53rd Tuesday. So required event is Monday, Tuesday, or Tuesday, Wednesday. So probability of 53rd Tuesday, therefore probability of 53rd Tuesday is equal to 2 by 7. So this is required probability. An experiment succeeds twice as often as it fails. Experiment succeeds twice as often as it fails. So here we suppose, let the probability of success P and probability of failure is Q, and given that probability of success, experiment succeeds twice as often it fails, so 2 times Q. Now we know that P plus Q is 1, so that means 2Q plus Q is 1, so Q is 1 by 3, Q is 1 by 3, so P is 2 by 3. Now question is, find the probability that in next 6 trials there will be at least 4 successes. So number of trials, six. Now see, word is next 6 trials. That means suppose here experiment is performed how many times? It is performed how many times? Then next 6 trials, that means after some trials, in next 6 trials, 1, 2, 3, 4, 5, 6, in next 6 trials, probability that there will be at least 4 success, means 4 success or 5 success or 6 success, because each action is independent. Every action, every trial is independent, so there is no effect of this word next. You are given to confuse. Find the probability that in next 6 trials, or if this word is not given, only this is given, probably that in 6 trials, means the first 6 trials or next 6 trials. So meaning of this is that in next 6 trials, that means after first 6 trials, if these are first 6 trials, 1, 2, 3, 4, 5, 6, after first 6 trials, these are next 6 trials. So here there is no effect, because each action is independent. So in calculation there is no effect of this next word. So if next word is given or not given, first 6 trials or it is matter of next 6 trials, we do by the similar method. So probability of success, X means number of success, X equal to X number of success. So probability of success is formula NCX P raised to X Q raised to N minus X, and X takes values 0 to 6. So here probability that in the next 6 trials there will be at least 4 successes, is probability that number of success is at least 4, means 4 or more than 4. That is probability that number of success 4 or 5 or 6. Now putting values we can calculate. So here N is, say here N was 6 trials. So next step from this is that this was that X equal to X, N was 6 CX, P was 2 by 3, 2 by 3 raised to X, 1 by 3 raised to 6 minus X. So using this formula, putting here values, here x is 0, 1, 2, 3 up to 6, 4, 5, 6. Okay, so arranging properly. So this is equal to, putting here 4, 6c4, 2 by 3 raised to 4, 1 by 3 raised to 6 minus 4 is 2, plus for 5 success, putting here 5, 6c5, 2 by 3 raised to 5, 1 by 3 raised to 1, and putting 6. So 6c6, 2 by 3 raised to 6, 1 by 3 raised to 0. So this is equal to 6c4 is 6c2. 6c2 is 6 into 5 upon 2 into 1, that is 15. 30 upon 2. 6 into 5 upon 2 into 1. So 15 into, this will be 2 raised to 4 upon 3 raised to 6. 3 raised to 4 into 3 square, 3 raised to 6. 6c5 is 6c1. 6c1 is 6. 2 raised to 5 upon 3 raised to 6. Plus 6c6 is 1. 1 into 2 raised to 6 upon 3 raised to 6. So here are 2 raised to 4 upon 3 raised to 6 common, into bracket 15 is left, plus here 6 into 2, 12 is left, plus here 1 is left, 1 into 4, 2 square is left, so 1 into 4 is 4. So this is 16 plus 15, 31 into 2 raised to 4 upon 3 raised to 6. Using calculator, you can calculate this value. How many times must a man toss a fair coin? How many times a man must toss fair coin so that probability of having at least one head is more than 90%? We suppose that a man tosses a fair coin n times, and we take getting head is success. Let me take success means getting head. So probability of success is 1 by 2 and probability of failure is 1 minus 1 by 2, that is 1 by 2. Now given that probability of having at least one head is more than 90%, now probability of having at least one head, is more than 90%. So we want probability of, before taking this statement, let me take formula. X equal to, we take number of success. X is number of success. So probability that X takes value X is MCX P raised to X Q raised to N minus X. That is number of success. N is, we take N. Man tosses a fair coin n times. So number of trials N. So MCX P is 1 by 2 raised to X. Q is 1 by 2 raised to N minus X. We don't know about N. We want to find N. So here Probability that x takes value x is ncx into 1 by 2 raised to, here joining these two, value is n. Now we are coming on this point. Probability of having given that probability of having at least one head is more than 90%. That is probability of number of success. See, at least one success, that means more than or equal to 1. At least one, not less than 1. 1 or more than 1. So probability of 1 or more success, it is more than 90%. More than 90%. So this is more than 90 by 100. And we know that here this x takes values from 0 to n, and sum of probabilities of this number is 1. So probability that x takes value more than 1, so this means sum of probabilities of these values, p of 1 plus p of 2 plus p of 3 up to p of n. So sum of probabilities of this value is equal to 1 minus probability of 0. That means 1 minus probability that x takes value 0. This is more than 9 by 10. That is p of x equal to 0. This number I am taking on that side, and so this will be smaller, and 9 by 10 I am taking on this side. So 1 minus 9 by 10, 1 minus 9 by 10, that is 10 minus 9, 1 by 10. Term is taken on that side and inequality is reversed. Now probability that x takes value 0, putting here 0, nc0 into 1 by 2 raised to n is less than 1 by 10. X I have taken 0. nc0 is 1. So this means 1 by 2 raised to n is less than 1 by 10. These are positive values. So that means taking reciprocal, 2 raised to n is more than 10. Now see, this is true for n. See, 2 cube is 8. 8 more than 10 is not true. 2 raised to 4 is 16. 16 is more than 10. 2 raised to 5 is 32. 32 is more than 10. So this is true for all values more than or equal to 4. So answer is, man must toss a fair coin 4 times. How many times must a man toss a fair coin? So therefore a man must toss a fair coin at least 4 times. In a game, a man wins a rupee for a 6 and loses a rupee for any other number when a fair die is thrown. The man decided to throw a die thrice, but to quit as and when he gets a 6. Find the expected value of the amount he wins or he lost. So game is, a man is tossing a die. Maximum he is asked to toss 3 times. But as he gets 6, it stops the game. On the first throw, if he is getting 6, game is stopped. On second throw, if it is 6, then on second throw game is stop. In third throw if 6 is obtained, that game is stopped. So maximum 3 times. So whenever he is tossing, suppose he is getting 6 on third throw, that means on first and second throw he is getting another number. So on every another number he lost 1 rupee, and when 6 is obtained he gets plus 1 rupee. So on 6 he is getting plus 1 rupee, and on any other number he is getting minus 1 rupee. He lost 1 rupee, that means getting minus 1 rupee. So here tossing a die, we suppose probability of getting 6 is 1 by 6 and probability of getting other number is 5 by 6. Maximum man is throwing 3 times. So a man throws a die maximum thrice until he gets 6. So we check all possibilities. Let A be the event that 6 is obtained on first throw. When a man is tossing a die on the first throw, 6 is obtained, game is over and he is getting 1 rupee. So probability of this event, probability of event A, it is equal to first throw 6 is obtained, so probability of getting 6, that is 1 by 6. So that means probability of getting plus 1 rupees, plus 1 rupee is equal to 1 by 6. So winning amount plus 1 rupees. So these statements we will put later on. First of all, we discuss about events. Then these numbers we will relate later on. So now we come on next. B. Suppose 6 is obtained on second throw. So probability of this event B. See, first throw he is getting other number. So first throw, then he is doing second throw. So first throw probability is 5 by 6, second throw 1 by 6. See here, occurrence of 2 independent events simultaneously. Getting other number, then in the next action getting 6. So occurrence of 2 events and both are independent. So probability of occurrence of both events at a time is product of their individual probability. So this is 5 by 36. We take C. C is event that 6 is obtained on third toss or third throw. First throw non-zero, other number, second throw other number, and third throw 6 is obtained. So probability of this event is, see, first throw other number, second throw other number, third throw 6 is obtained. So occurrence of 3 independent events simultaneously. So probability of this event is 5 by 6 into 5 by 6 into 1 by 6. So 25 by 216. Suppose one more possibility. No any throw 6 is obtained. No any throw. In any throw 6 is obtained. That means no any 3 throws, man is throwing thrice, 6 is obtained. So probability of this event is first time no other number is obtained, second time other number is obtained, and third time also other number is obtained. No any time 6 is obtained. And he is not allowed to throw fourth time, maximum 3 times. So and 3 times, these are the possibilities of throwing coin. Throwing a die 3 times. Sorry, this is 216. 216. 125 upon 216. Now we relate these probabilities and these events with numbers. See, when event A occurs, here I am putting winning amount. When event A occurs, on the first throw he is getting 6. So winning amount is plus 1 rupee. He is getting 1 rupee. When event B occurs, when this happens, means first throw non 6 number is obtained. Other number is obtained. So winning amount is minus 1. He has to pay minus 1 rupee. Loss 1 rupee, that means winning amount is minus 1 rupee, then getting plus 1 rupee. So this is 0. If C occurs, if event C occurs, means first time other number, second time other number, third time also other number. So all 3 times he is losing 1 rupees. So winning amount is minus 3 rupees. We are defining this amount in these words, winning amount. So putting minus. And when D occurs, sorry, see I have done here mistake. C means 6 is obtained on third toss. So on third toss plus 1 is getting. So this is minus 1 rupee. And on occurrence of D, he is losing 1 rupee every time. So minus 1, minus 1, minus 1, that is minus 3 rupees. So if we define these numbers as random variable, now we define random variable x. X be winning amount. So probability of this winning amount we can put in tabular form. Say here x takes value 0, plus 1, plus 1, 0, minus 1 and minus 3 rupees. These are values of x. Winning amount we are taking as random variable. Now probability of winning amount 1 rupees, it is equivalent to say probability of event A. So probability of 1 equal to probability of A, it is 1 by 6. Probability of getting 0 rupees is equal to probability of occurrence of event B, and probability of event B is 5 by 36. Probability of winning minus 1 rupee equal to probability of event C, that is 25 by 216, and probability of winning amount minus 3 equal to probability of event D, and that is 125 upon 216. So here expected value of winning amount is expected value of x that is winning amount. That is E of X. So sigma xi into Pi. So that is 1 into 1 by 6 plus 0 into 5 by 36 plus minus 1 into 25 by 216 plus minus 3 into 125 by 216. So that is, this will be 1 by 6, this is 0, minus 25 by 216 minus, this is 375 by 216. So LCM is 216, this will be 36 minus 25 minus 375, that is 400. So this is minus 364 upon 216. Now simplifying this, 6 plus 3 9 plus 4 13 divisible by 2. So 1 into 2 2, 8, 182 into 2 364, and this is 108, again divisible by 2, or we can, if possible, we divide by 4, not divide by 4, divisible by 2. So 9 into 2, 91 into 2, here 54 into 2. So this is minus 91 by 54. We can calculate this by calci. Question is, assume that the chance of a patient having a heart attack is 40%. It is also assumed that a meditation and yoga course reduce risk of heart attack by 30%. Say 30% will be reduced, is 30% of 40, and prescription of certain drug reduce its chance by 25%. Without doing anything, risk is 40%, and after doing something, it reduce by 30%, means 30% of 40 and 25% of 40. At a time, a patient can choose any one of two options with equal probabilities. It is given that after going through one of the two options, the patient selected at random suffers a heart attack. Find the probability that patient followed a course of meditation and yoga. So here we suppose there is a patient choose any one therapy, that is meditation and yoga, or he choose prescribed drug. So any one therapy, any one way to reduce heart attack, he choosing So we suppose that E1 is the event that patient choose meditation and yoga, and E2 is event that patient choose prescribed medicine. So patient is doing this action or this action, and after doing any one of this action, suppose patient suffered from heart attack. Patient is doing any one of these two, even though there is possibility of heart attack. So here in question we are given that after going through one of the two options, the patient selected at random suffers a heart attack. It is given. So after going through one of two options, patient selected at random suffers heart attack. So we take patient suffers heart attack. This event we take event A. So say here E1 is the event that patient selects meditation and yoga. E2 is event that patient selects prescribed medicine, and E is the event that patient suffers a heart attack after choosing. So given after going through one of the options. So after going one of the options, that is event A. This is given. So if this is given, find the probability that patient followed a course of meditation and yoga. So we are asked probability of this event. This is given, then find probability of this event. So here it's application of Bayes theorem. This is given. So here required probability is, see here I am putting required probability, that is P of probability of A is given, then probability of E1. So P of E1 by A. So it is P of E1 into P of A by E1 upon P of E1, P of A by E1 plus P of E2, P of A by E2. So putting values in this formula, we can find required probabilities. So first of all, we have to determine the method, that which rule will be applicable. So you have to understand the story, that what is given, what is required. Now let me calculate all values one by one. Now probability of A by E1, that means patient chose meditation and yoga. If he selects meditation and yoga, then probability of heart attack. So here given that if he chose meditation and yoga, risk of attack is reduced by 30%. Previously it was 40%. So previously it was 40%. Then it will be reduced by 20%. It is reduced by 30%. So 30% of 40%. So 30% of 40%. That is, this can be expressed as 40 by 100 minus 40 by 100. This is 40% of 30%. So that is 40 by 100 common. So 1 minus 30 by 100. So that is 40 into 70 upon 1, 2, 3, 4. So this is 28 by 100. So it is 0.28. Now P of A by E2. P of A by E2. That means if patient selects prescribed medicine, if prescribed medicine is selected, then what is probability of attack? Previously without doing anything, probability was 40%, that means 40%, now it is reduced, 40% minus, now how much it is reduced? 25%. So 25% of 40%, so 25% of 40%. So that is, this is equal to 40 by 100 minus 40 by 100, 40%, 20 into 25%. So this is 40 by 100 common, 1 minus 25 by 100. So this is 40 into 75 by 1, 2, 3, 4. So this is 0, 0 is cancelled. 75 into 4, 300. 300, that is 30 by 100, so 0.30. Now putting these values, P of E1, P of E1 is 1 by 2, P of A by E1 is 0.28 upon 1 by 2 into 0.28 plus 1 by 2 into 0.30. So this is 0.28 upon 30, 40, 50, 0.58, that is 28 by 50. So 29 upon, this is 14 upon 29. This is required probability. Say bag 1 contains 3 red and 4 black balls, and bag 2 contains 4 red and 5 black balls. One ball is transferred from bag 1 to bag 2, and then a ball drawn from bag 2. The ball so drawn is found to be red. Find the probability that transferred ball is black. See, explaining story by diagram. Here, this is a bag 1 in which 3 red ball and 4 black ball, so total 7. Bag 2, here I am showing 2 times. This is picture of bag 2. This is bag 2. Bag 2 contains 4 red and 5 black balls. 4 red and 5 black balls. 4 red, 5 black balls. This is bag 2. Now procedure is, a ball is drawn from bag 1. So there are 2 possibilities. Either drawn ball, it can be red if red is shifted, or second possibility is it can be black. Red ball is shifted or black ball is shifted. If from bag 1 to bag 2 a red ball is transferred, then here number of red ball will be increased, so it will be 5 red balls, and total will be 5 plus 5, 10. And if transferred ball is black, so number 1 will be increased in black ball, so total will be 10. So either this happens or this happens. After transferring ball, now select one ball from this second bag, and a red ball is selected. Red ball is drawn. Given red ball is drawn. If this is given that red ball is drawn from bag 2, what is the probability that transferred ball is black? So we are asked probability of previous event. Suppose this event is A. This event we say E1, this event is E2. So E1 is event that transferred ball is of red color. E2 is event that transferred ball is of black color, and E is the event that red ball is drawn from bag 2. Now this event is given. So say here required probability is, if this is given, then what is probability that black is transferred? So P of E2 by A is required. Find probability that transferred ball is black given that red is drawn from bag 2. So this is by Bayes theorem, P of E2 into P of A by E2 upon P of E1 into P of A by E1 plus P of E2 into P of A by E2. So we require here these values. Now from this calculation, here probability that this action occurs, red ball is transferred, that means from bag 1 a red is drawn. So there are 3 reds, so 3 by 7. 3 by 7. P of E2, that is black ball is transferred. From bag 1 black ball is drawn. So 4 by 7. 4 by 7. P of A by E1. If E1 occurs, probability of A. If E1 occurs, then probability of this action. So if E1 occurs, take a red ball from bag 2. So now if red ball is transferred, there are 5 red balls, and again take red, so 5 by 10. So 5 by 10. And P of A by E2. If E2 occurs, then take a red ball. See, every time, both times we are finding probability of red ball. A is for red ball. So if E2 occurs, then here red ball remains same, but total is increased. So 4 by 10. So this is 4 by 10. So putting values in this formula, this is equal to P of E2 is 4 by 7 into A by E2, 4 by 10 upon 3 by 7 into 5 by 10 plus 4 by 7 into 4 by 10. So this is equal to 4 into 4, 16 upon 15 plus 16. So 16 by 31, that is required probability. An electronic assembly consists of 2 subsystems, say A and B. From previous testing procedures, the following probabilities are assumed to be known. Probability that A fails is 0.2. Probability that B fails alone is 0.15. Probability that A and B both fails, that is 0.15. Evaluate following probabilities. Say here A fails by B has failed. A fails alone. Say we keep this in notations. Let me take A dash be the event that A fails and B dash be the event that B fails. So A fails, so probability of A dash is 0.2. B fails alone, probability of B fails alone. This is 0.15. This means B fails alone, that means only B dash occurs. So this can be expressed as probability of B dash minus probability of A dash intersection B dash. Only B fails. If this is X, this is Y, then only Y occurs. So probability of Y, only Y occurs, that is probability of Y minus probability of X intersection Y, like that. So this is equal to 0.15. A and B both fails, and A and B both fails, that is A fails and B fails, it is 0.15. So from this statement and this statement, here we have taken these two statements, and from this statement we are doing work here. So now P of B dash, this is minus 0.15 is equal to 0.15. So P of B dash is 0.30. Now see, first question is probability that A fails by B has failed, that is probability of A dash by B dash. And by definition, probability of intersection upon probability of this condition. And here this is given 0.15 upon P of B dash, here we have found 0.30. So 1 by 2, that is 0.5. And second question is A fails alone. Probability that A fails alone, that means probability of A dash minus, it is equal to probability of A dash minus probability of A dash intersection B dash. A fails alone, so A dash means A fails minus both fails. So common failing students are removed. So that is probability of A dash is 0.2 minus 0.15, so 0.05. If each element of second order determinant is either 0 or 1, what is the probability that value of determinant is positive? Say here in determinant, second order determinant, here each element is either 1 or 0. So here we say this is A11, this is A12, A21, A22. Each entry is either 1 or 0. So A11 can be selected by either 0 or 1. A12 0 or 1. A21 put 0 or 1. That means each Aij can be selected by either 0 or 1. That is by two ways. Each element can be selected by two ways. So total number of such determinants, is equal to, n is equal to this place by two ways, 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 that is 16. Now we want probability that value of a determinant is positive. So determinants having a positive value are, let me think, all such determinants from this collection. If I keep here 1 1, then its value is positive. If I keep here, suppose only two possibilities, 0, sorry, we need value of determinant positive. Now if I keep here 1 1 0 1, then its value is also positive. If I keep 1 1 here 0 here 1, then its value is positive. Now no any choice is left, only there are such three determinants. So R is equal to 3. So event contains only these three elements. So required probability is R by n, that is 3 by 16.